it's lucky I have a newsletter so I can read the resume of our speaker tonight. But I did want to mention that I was talking to our speaker about this evening's talk, and he said, hey, would you like another speaker? He's British. And I said, well, we can't really afford to fly people, over from England for our meetings. And he said, well, coincidentally, he's going to be in Houston, Texas in September. And for the cost of a ticket from Texas, we can get this guy. And I said, that sounds great. We'll take him. So we have Tom's friend coming from England. He is also an aquascape planet aquarium guy. He had an article in Amazonas magazine this month. So if you get Amazonas, there's a huge spread in there by George Farmer, who will be our speaker in September. I just wanted to give you that warm up before I introduce tonight's speaker. So tonight's speaker is far, far older than he looks.
Nice.
He's maintained planet aquariums for more than 15 years as a business. He's collected his own plants. He started his education after the age of 30, and he is now Dr. Barr. He has an online plant forum that is very well known. I don't need to mention the name for those of you that do keep aquatic plants, but for those of you that don't, it is the Barr Report, and it's probably the best online planted aquarium resource, so I highly recommend you check it out. He's written articles for just about every major publication, as well as some scientific publications. He's obviously spoken to us. He's spoken to lots of different clubs. He's taught biology at the community college level, and tonight he's here to teach us about the planet aquarium. Let's give a very nice, warm welcome to our speaker tonight, Dr. Tom Barr.
Makes me sound important.
You are.
So anyway, so this talk, I focus a little bit more on sediments and fertilizers for aquatic plants. This is a native plant to the southeast of the United States. It's the Carolina compressor. Now, if you live in Japan or Europe and you see something like this, you go, oh, wow. But here in the United States, it's a native plant, not a big deal. But, if we saw something from, the southeast Ghats in India, some little cool plant, we could get, ooh. And fish collectors feel that way too. Most everybody here is probably started off as a fish person and maybe got a little bit into the plants or added plants as a sort of a secondary afterthought. So did I. I mean, I did that, and then, then I kept getting worse and worse and worse, and then I have the disease. So now I've got the plants. Good thing about it though is I can still keep fish, but I just have a bunch of nice plants as well. It's not nice fish that I like. So that's good, unless you have fish that like to eat plants, but there's a way around that. And I can help anybody that's interested in that too. So introduction, there's basically kind of three main elements that grow plants. One's light, obviously. The other is carbon dioxide, CO2. Now, you don't have to add that to the tank. You can get a little bit from the air, or if the plants are up above the water surface or at the surface, they can get change CO2 with the air pretty fast. Underwater, though, the rates of CO2 diffusing into water is about 10,000 times slower than it is in air. And so that's why we have to add the CO2 to the water to get plants to grow a little faster. It gets depleted really quick. So it doesn't recycle too well from the atmosphere into the water. And then the last one's nutrients. Most people know about nutrients. We add them to gardens and things like that, fertilizers. Anything else? Well, maybe just general care of your fish tank. Cleaning things, doing water changes, cutting those plants. A lot of tanks won't grow too well unless you cut, trim them and cut them. And that's the same way with bonsai as well. If you don't cut those bonsai, they're not going to grow that well. Oh, that's hot.
Sorry about that. So you're
is
that better? You want them back on?
You want them back on or not?
A little bit.
A little bit? Yeah, we need some light so people don't say, hey. That's fine. I don't care either way.
It's an adjuster, but it's not adjusting. So.
At least you can, see me a little better that way, I think.
No, principal, we want to say
Am I
it.
speaking loud enough for everybody to hear?
No.
No?
That's better.
Okay.
That's good.
I can talk louder. Don't worry. Yeah, that's one of my tanks from, I think a couple of years ago. And it's just, eye candy, keep you awake. And then I'll put you to sleep with this one. So I'll just explain this. This is just a matrix, and basically you have CO2 on this side here, and on this side we have increasing light. So we have low CO2 going down to high CO2. And this is about what a lot of aquarists keep, in those CO2 enriched aquariums. Maybe they keep their light out here, really high light, something in that range. But in each one of these little blocks, there's a percent, 1.1%, 3.8, and 4.1%. That's at pretty low light. I converted it to micromoles from lux. And then also here we got pretty high light. Here very high light, probably reef range for SBS reef keepers. This is basically not adding any CO2 at all to your tank. And this is adding just a little bit, and this is adding a fairly rich amount. So, in all cases, they used a plant and they measured the relative rate of growth for the plant over a course of per week. So we have 1.1% growth, extra growth, new growth per week of the plant with very low light and no added CO2. So that's the worst case scenario. It's pretty much just very little light. You're not adding CO2, but you still have growth. Now here we still have growth also, but what's changed? We have 17, almost 20 times fold in growth rates. So we have much more growth. So all these conditions grow plants. The only difference is what? The rates of growth, basically. Here we still have the same amount of light, but I get 4 times more growth by just adding CO2. And this is this range in here. This is usually what the authors of this particular study suggested: rich CO2 and low to moderate light. That's the best. That gives you the best management chance of success of all the different methods that are out there. Obviously, this one's easy, especially have like a floating water sprite in a tank with a single strip of fluorescent. You're going to grow it. It'll grow probably pretty well, especially with the tap water we have here, which is actually very, very good. Here's some non-CO2 examples. A lot of people think these non-CO2 aquariums are kind of ugly or ratty, or they just look like these unorganized jungles. And that's not necessarily true. It's just that a lot of those folks are neglecting the tank and not sort of picking at it or cleaning it or thinking up of a nice aquascape that would look nice over time. But here's 3 examples. This is just some crypts, lily and some valves, some nice rasporas, pork choppers. This is just a little nano tank, maybe a gallon. I got a little plant growing on the top in the filter. And then just some java ferns, some shrimp. This is a nice tank I had in my, when you first walk in. And it's a bunch of plants sort of growing up on the top, open top. It's a nice looking tank. That's a very easy tank to take care of. You can breed, I bred a bunch of rare placos in there for about a year and a half. Did really nicely. Now it's a SBS frag tank. So here's another tank. This guy just used the glutaroaldehyde, or sometimes it's called XL, CChem XL. You add a little bit to it, and you can grow most of these species together. What happens in these non-CO2 tanks, at least in the submersible case, is plants that can photosynthesize the first at the lowest light levels will gobble up all the CO2 first. And these guys down here, they don't have as much light. They're not going to be able to photosynthesize or grab that CO2 out. And so it's a competition for CO2 between plant species. That's why a lot of times you get just 1 or 2 species that really dominate in these non-CO2 tanks. But if you add CO2 gas to this, they all grow fine. So that's if you want to grow a lot of species together, CO2 is probably a good idea to use.
What's the purpose of the glutaroaldehyde?
Glutaroaldehyde, they said it's like carbon enrichment, but it's actually probably more At the rates we're dosing it at around 2 to 2.5 parts per million. So that's only going to add, if you metabolize that by bacteria, it's only going to add about 2 or 3 parts per million CO2, which will be gone in about 30 minutes. So it's not really adding CO2. They call it a carbon supplement. That's baloney. I would use more. Well, I could use steer manure. There we go. That's a good family group here. So it's actually something that more kills algae. It's general biocide. And so it will cross-link proteins. And so it kills algae quite well. Plants have another enzyme that's able to detoxify it, and they also gain sort of this resistance to it. Algae, not so much, especially the red algae and some of the diatoms, some of the others. Green algae, not so much. So it's actually more an algicide, but it helps the plants seem to grow a little better together. Here's some other things. These are sort of moderate CO2 examples. They've added just a little bit of CO2. Now, that's a pretty nice looking tank. Here we've just got a little bit of moss, a little bit of hair grass. Not very much plant biomass actually. And there's plenty of room for the fish. They got a bunch of tiny little fish. You know, most people think, I want more fish than that. And there's no rule that says you can't do that. I saw a very nice tank a couple days ago. Big Asian arowana in there, big red dragon. Guy in Thailand had one. Gorgeous tank, gorgeous fish. You know, there's no reason why you can't have that. Here, there's not much plant biomass yet, so I don't really need as much CO2. Plants are still going to grow. They're going to grow a little slower, but you don't necessarily need to have a lot of CO2 in a lot of cases. Here's higher CO2. This is another native plant from the southeast, Rotala Razamore, also called Rotala Sunset. This stuff grows like a weed, but when you chop it and replant the top, some of the tops will turn necrotic. And so I had this nice stand of it, and I kept chopping it, and eventually lost a lot of the stems from that. It's just kind of one of those plants that was a hard plant to take care of over time. So I changed it over and did some different things. This is my 120 about maybe, I guess, in November or so. No, this is sooner than that. This is later than that. Probably February, March, something like that. These plants here, 30 bucks each. This plant, 20 bucks for a few stems. 6 stems for 45, 25, 16 for those. Golf ball of that, 30, 40 bucks. So, you know, I've got this fairly well organized, all these different rare species, but I have a reason to go in there and take care of my tank. I have some motivation. I'm like, okay, I can make some money now. I can be a farmer. These guys, I probably split these guys once every month or two. So 30 times, 20? That's 600 bucks every couple months, just for that one little area. Some of these others, so you're looking at $1,000 a month, and they're a lot easier to ship than fish. And if they die, that's in the compost. I don't feel guilty. So, but that might be a motivational factor for a lot of people. If my fish are breeding, well, I'll probably take care of them a little bit more. I'll tend to them. A little more interesting. My tank's growing well. I don't have it, not always fighting algae. Every time I get ahead on this, something happens and there's a disaster. But if you do get to the point where you can keep plants pretty well, then it's, you can make good money off of it. These are Bucicefaloandras. One of those plants are like 30 bucks each one. And that tank you saw before just had a few plants, and the modern one, they all grew into this. So it took me about a year and a half, but each plant's 30 bucks in that picture. So, and they're like Anubis, so they're bulletproof and they're easy to care for, but they grow slow. And so, this is my naturescape, sort of a nature style. I decided to pick these white neons because they would contrast well with the dark colors of the plants. So looks kind of cool. It's a nice tank, and man, I don't do a whole lot of work on it either. I just change the water once a week, once every 2 weeks, fertilizer twice a week, and feed the fish, you know. And the plants grow kind of slow, so if I don't forget to trim a week or two, I'm all right. Had to trim finally after about 3 or 4 months, and I had like, 100 plants. So that's like, $3,000 worth of plants. I'm like, well, I better not unload them all at once. Like De Beers Diamond Market, I must just few at a time. So, but yeah, they're starting to tissue culture them now, so the prices are dropping. But my plants are like this, the tissue cultures are like that, so it's like basically 3 to 6 months better quality plant. This is an idealized sort of CO2 concentration for a planted tank that adds CO2. And on the bottom scale here, we have hours. This is basically a whole day. And the lights come on right about there. CO2 shoots way up, plateaus. Lights go off here, drops back down. You stop adding it. Your oxygen levels come up to maybe about 130, 140%, and drop off a little bit. And that's sort of what you want. The top line up there, the red one up there, that's the lethal threshold. That's where your fish are going, I don't like this, I'm kind of acting drunk, I'm near the surface. So CO2 is the #1 killer of fish for planted folks. They tend to be very loose and not too careful with the CO2. And I've always been really kind of paranoid about CO2 since I started the hobby. So I haven't killed many fish with most people I know of have killed quite a few fish with the gas. And that scares a lot of people into using it. They don't quite understand the utility of it either. But if you're able to sell $1,000 of plants every month easily on the side, and then that CO2 starts sounding a little bit more interesting. So I mean, it depends on your motivation. Some people want a really nice aquascape, a nice garden. Some people want to sell plants. Some people want to do both. You have to sort of find your own motivating factor. What gets you into that tank and takes care of it, rescapes it, does other things. I redid this tank several times, switched plants around, new plant there, different plant species down here. I raised probably about 400 or 500 of these little things. They call them Turrithria. Another common name is blood vomit. It's from Australia, and they came up with the name. I didn't. Must be a pub crawl thing. I don't know what. But all right, so I raised 500 of them, and then I got rid of them, tried something new, and then I decided to go back and see if somebody had some that I sold to. Not anybody. I couldn't find. I found like one guy had them, and he only had 1 or 2, and they were on their way out to death or something like that. So a lot of these plants will sort of have this boom bust cycle in the hobby also. This is a non-idealized CO2. Lights come on here. CO2 really takes a long time to get up to that point, and then it takes a long time to come back down. If you have a canister filter, this is more likely the pattern that happens. And you see you get above that lethal threshold. So for a few hours right before the lights go off, those fish are up near the surface. So if you adjust your CO2, don't go off to work for 8 hours and then come back and your fish are all at the surface. You don't want that. Wait for a Sunday or Saturday when you're around, or do it at night and then watch. Change your hours around so you're around so you can sort of observe what's going on. Observation is probably one of the best ways to sort of adjust CO2. The other probably best way would be relative pH. And if somebody wants a little more information, they can ask me later about that. All right, now let's talk disasters. I went away to the Philippines for 2 weeks. I came back to that. I don't know if the resolution's good on that, but it is covered in hair algae. Lots of it, lots and lots and lots. And this is the tank 2 days later. So, and it's stayed this way ever since. Now, a lot of people, online I get, this is my tank, I'm gonna die. So I understand the feeling, but I didn't really cure this with some silver bullet or some miracle cure or some special snake oil. It's fresh squeezed, of course, in a bottle, and all of a sudden I have a magic cure tank. I trimmed all these plants pretty well, cleaned it, did a couple water changes, manually pulled them out, got all the algae off by hand, preened them, and then replanted it. Some stuff like, this stuff here, I just pulled it out by the hand. This I mowed, a lot of plants in the background, cleaned, added CO2. CO2 was off for 8 days. That's a good reason why. Usually most of your algae problems are CO2 related, at some level. We also have stuff like this on canister filter tanks. They have the surface scum. And that basically blocks any exchange of oxygen from the surface down into the tank. And it locks that CO2 in too. And so as you're adding CO2, it can't degas out a little bit. This tank here, I have a surface skimmer that sucks all that scum off. So the rate of CO2 going in and out is going to be the same, and oxygen as well. So I have a lot more stability here than I do there. Small little tank, there's very little distance for that CO2 to move up and out. So it's going to transfer out of that tank a lot faster than a bigger tank. Or if I had a narrow tank like this 55, it's going to take a lot longer for that molecule of CO2 to degas here than a wide surface, say like if it's a 120, something 2 feet wide instead of a foot wide. And you can compensate for that with more current and other things, but generally speaking, these wider tanks will degas a little faster, and shallow tanks will degas faster. And this kind of goes back to something called Fick's first law of diffusion. Basically, the flux, the amount of degassing going out is proportional to the concentration. So if you have a really high concentration of CO2, the flux is obviously going to be coming out faster out of that tank. So that sort of refers to degassing rates. A lot of people think about just adding the CO2. They don't think about how much is coming out as part of the stability. And what you want is a stable CO2. And so if you think about how much is coming out as well as how much is going in, then you get this nice balance. And we always hear about, you just need to balance your tank. You need to balance your CO2. A lot of people don't think about that part. They just think about adding it. That applies to oxygen as well. So this tank, I have a wet-dry. Oxygen's independent of CO2, so my oxygen levels are real high in here too. And I can muck this tank up, overfeed, do whatever. Oxygen levels are still going to be at near 100% or higher all the time. So that's a good environment for the fish. And the more oxygen you have, less they're going to get drunk on the CO2. So I have more wiggle room with the CO2 if I have high oxygen. So that's something to think about also. I think I talked about most of these. What happens when you have sun? Talk about evaporation wash. Here's a good one. Inline canister filters, they slowly clog. And so as they clog, flow also clogs. So it slows down. So the mixing of that CO2 and the water and also the surface turbulence slows down. So your oxygen levels go down also. And your CO2 can get kind of high. So if you clean your filters off and just basic stuff. Also, if you trim your tank often, that's also a good idea. Keeps everything stable. But like myself and every other hobbyist, we all neglect tanks at some point, if not as just our normal routine. So we got to be honest with ourselves here. We're all fish killers at some level. And if not yet, you will. So you got to be honest with yourself about it too, and just kind of like, what are you going to do? And you can set up things and do management approaches, say a non-CO2 tank with plants. That works really well for your neglectful, behavior. You know yourself better than anybody else about that. So that's just something to ponder. That's like the filter I used at the start. Just a gas tank. Regulator, solenoid to stop the flow of gas at night. a little valve to control the flow. I just got a wet-dry filter. I sealed the top so CO2 gas doesn't shoot out when it comes down from the pre-filter. Water comes out, goes back to the tank, feed the CO2 right into the filter.
What's the power head for?
What power head?
Isn't that for a Vortex or I could,
Oh, that there?
yeah.
I don't actually use that. I tried it out. I didn't need it for this tank. I was adding a little bit more current. I thought I needed more current. I didn't really. So I took it out. I don't actually use it. I use it on a reef tank instead. But yeah, good catch.
Why do you have the CO2 in the sump as opposed to directly in the tank?
Just because it's out of the way. I don't like stuff in my tank. Less junk in the tank. A lot of these ADA aqua design mono tanks have, you know, the glass diffusers. They got other things. They got the tubes and all that other stuff. They're kind of hard to clean. They're glass. They're easy to break, and I just prefer less stuff in there. Honestly, I mean, they make glass overflows. Mom made for like $200 though. They're only good for maybe up to about a 40 gallon tank maybe, but I just use this other stuff. It's just easier and gets everything out of the tank. And, you know, the CO2 hits that impeller, gets ground up, atomized, and goes through about 6 or 7 feet of pipe back to the tank. It's pretty well diffused by the time it hits the tank. You can add one of those clear water filters there right after the pump too, and that'll catch most of the small stuff and give it more dwell time. And then back to the tank, and then all of it's always pretty close to 100% dissolved at that point. Other people will also use just a separate loop. They'll put a power head in here and feed the CO2 into that. And that'll come out and go through a canister, and then back to the tank, and then back. And then that's almost 100%. There's no mist at that point. 100% dissolved. So that's, you know, there's several ways you can do that. Bean animal overflow, funny name, but works pretty good. This also makes your overflows almost 100% dead quiet. So basically you have one that's sort of an emergency overflow, one that is going full siphon. There's no air getting sucked into this one. And this one you adjust with the valve to get just a little bit in there. And you want to run, you know, one on full bore, and then this one just a little bit choked. So you have, so it doesn't suck in any air. And then this, if anything clogs this one for any reason, this one's your emergency overflow. And it reduces noise and degassing. The more quiet it is, the less degassing you usually have. So your system's a little more efficient with using the CO2 gas, and it's more stable too. Then fertilizers, there's 3 basic ranges. None, or fish waste. You don't add anything other than fish and fish food. Some people use Rich sediment tabs, and that's it. Some people use the water column. I actually use all 3, and good reason for that. I like fish, and the reason why I got in the hobby. Rich sediment, it's easy to add, and water column, I add that 2 or 3 times a week. That's not hard either. So yeah, combination of all 3. I had to cover all my bases that way. So, good question. A lot of times it comes up in crop management as well, and in agriculture around here, UC Davis, Big Science and Agriculture, is what's a non-limiting level for growth for plants. And on the bottom we have concentration of minerals or dry matter, so the nutrients that you get from fertilizers. You can also, the concentrations of fertilizer in your water column. And then on this axis here we have the growth or yield. And so you can just think of growth rate. So it goes up pretty quick and levels off and has this big, huge area here. So this is a huge target, really big target that we can hit without getting sort of these toxic levels out here. And so the simple way to do it is just to add, you know, kind of in this range here, and you get maximum growth from that. And you know, you're a long way from toxicity range. And as this stuff fills up, if you don't want to get kind of further out here, you just do a water change and you're back to this range once again. That's a pretty simple way to kind of manage your nutrients. You don't even need to test. You can actually use a mathematical formula, an infinite series, to predict what your dosing and what your range is going to be with that formula. It's mathematically possible. This is just some more of those Bucephalandras and some Brachiocardia. It's a nice little liverwort. Kind of grows a little slow than Riccia and most mosses. Has several different growth forms. Lower light, it's more sort of leafy like this, and higher light and more flow, it gets almost like a coral. It's more almost rounded balls. Pretty cool looking stuff then. This is an old paper, pretty famous paper for aquatic plant management. And Gerloff and a guy named Paul Krumboltz, who I knew and who I worked with a long time ago when I first got into the hobby. He's since passed on, but he was sort of the nutty professor, the crazy, nerdy professor kind of guy. And he did a paper for his master's thesis on nutrient uptake with in Valsinaria. And I actually took his data. They didn't have computers back in the 60s, produced nice charts and stuff like this. So I took his data and plotted it, on the rates of growth right there, and then on the bottom is ppm as N as nitrate. So ppm as N as nitrate, we've got to multiply that to add the extra oxygens. So this would actually be 45 parts per million of nitrate. This would be in the 80s, the 90s, 160, and the plant's growing pretty good. Here, this is probably more standard ranges that aquarists might keep with planting tanks, kind of in this range in here. But you could get 2 or 3 times more growth if we added 100 parts per million of nitrate. So, can I con anyone into dosing that much nitrate? Probably not, but we probably don't need to do that, because with fertile sediment, say like rich soils, ADA aqua soil, stuff like that, plus some EI dosing, 20, 30 parts per million weekly or whatever. Now you're getting close to non-limiting or close. A lot of people used to say that EI dosing was non-limiting, and that's not true. At least, that type of research suggests that it isn't. What about iron? I remember Bill Holler and some other folks in Florida had a paper on cheap chelated iron they were adding for hydrilla growth. They're up around 6 to 8 parts per million, not 0.6 or not 0.8, but 8 to 6. That's a good probably 10 to 20-fold range that even the richer people, the richer dosers are adding. So maybe we need to add more traces too. So that estimated index dosing, that's sort of that water change, add ferts, water change, add ferts kind of routine is not non-limiting, at least for valves, and probably not in general. And you include new soils. Well, so this is a look at sort of this rich soil, and this soil is very similar. This ADA aqua soil is very similar to the stuff when you drive across the causeway. That soil out there, it's almost identical to this stuff. The only difference is out there they add ammonia to the soil. They have a big rake. They pump liquid ammonia into the soil. They flood the rice paddy. They seed it. The seeds go down. They suck that stuff up and they grow real quick. The rice paddy drains off. Plants are nice and big. Shades out the weeds. That's how they do it. And that way, the flooding is to control weeds and to kill weeds. And flood control is actually the first sort of weed control that humans actually started to use. So here we have, this is the new soil, and that's the old soil after 18 months. And these guys here, nitrate, phosphate, and potassium are all, if you put an error bar on there, they'd all be statistically the same. Only difference is this guy, ammonia. And, just like, adding fish food to the tank, ammonia is going to be quickly, if you don't have any plants, it's going to be quickly turned into nitrate pretty quick. So bacteria attack the soil also, but the plants take up the ammonia pretty quick. And so after about a year or two, most of your ammonia is gone. But this stuff here lasts a long time. So your phosphate, your potassium, your iron, your other stuff, I don't have all of them up here, but all the other stuff lasts for probably 10 years. So that, you get a lot of use out of it. So if you want to keep adding more, you can add a little bit of urea, or liquid fertilizer, or you can just add more nitrate. Most people just add more nitrate. So you get really good growth for the first few months, and then it sort of tapers off. But you can keep that going. And this is just sort of another example of that from agriculture, where we have nitrogen uptake here. And this is from the soil, this part of the growth. And this top line is a little difference there is from the fertilizer that they're adding to the leaves, basically the water column. So that would be the water column plus the soil. So these, corn and other things are getting a lot of stuff from the soil. They can also take up quite a bit from the fertilizer as well. My main point here is to use both. Don't use one, just use both. It's not that hard to add fertilizer to the water column. That's a nice tank. So I mucked this tank up. I say this is that aqua soil, and this is old, and basically just mucking it all up, getting all the fines out, draining it, and then I'll refill the tank up and use it again. It takes some getting used to with some of these sediments. But I mean, you just do water change, muck it up, do water change, clean it out, use the water to water your lawn or landscape, things like that. That's what I do. I don't even use a sprinkler system or anything. All the water is just from the tanks. But basically just learn how to be careful and not make such a big mess. When you uproot plants, things like that, be gentle, put them in and pull them out. It took me a little getting used to because I'd been used to sand. Yes, in the back.
Do you use aqua soil exclusively?
Pretty much, just because I'm used to it, I know what to expect.
Have
It
you ever
also has a
dabbled
little
in,
bit more ammonia in it.
Have you ever dabbled in like dirted tanks or anything like that?
Say that again?
Have you ever dabbled in like dirted tanks or anything?
Have I dabbled in dirted tanks? Yes. I've gone off and just dug up some rice paddy soil out off woodland and shoveled in a bucket. I've actually shoveled a lot more delta soil than just about anything. A bunch of Tahoe soil as well for research. When I was at USDA's aquatic weed lab out there, we'd go out and that was like a thing we'd do every month, and then we'd have to wash the soil. I've got a lot more experience than I want to admit.
And you still prefer the aqua soil over that?
It actually grows plants about the same. It's more messy though. And if you put a cap of sand on top of that rice paddy soil, then, and you're careful about putting it in and out, then you're going to work pretty good. And it's cheap. It's free. Well, gas and buckets and your time. But the aqua soil is basically that stuff, but it's been compressed into an individual sort of grain, dried out a little bit, cooked just a little bit, so it doesn't dissolve and fall apart. And so it's all one homogeneous thing. So when I move the soil around or make slopes, redo it, I don't have to worry about that sand being in there looking tacky, have two different colors, things like that. But if you don't care about that, or you're planning just to put it in, let it go, and that's it, and you're not going to move things around, then it's a good option. But for me, because I like to aquascape, move things around, not so good. But it's 40, 50 bucks a bag for basically enough for about a 20, 30 gallon tank. So there's some trade-offs there. This is for rice. That was sort of my model plant at Davis because, well, an aquatic plant feeds the world, feeds more people than any other. All you gluten-free people, well, we like rice. So if you don't like rice, you're ricist. So, I learned that before I got into this hobby, so don't worry. So what's going on here, this is sort of a measurement of the soil through time. And up here at the start, it's regular soil, farmland soil. Then they flood the soil. And that's sort of what we're doing when we start a plant tank. We have this tank we put in our soil or whatever it is. This is for rich soil like Agae aqua soil or your rice paddy soil or whatever. I would recommend getting rice paddy soil if you live here. So, so yeah, you flood the water, and this is days after submergence. So after about 60 days, these are two different types of soil. This soil's better. This is more like our sandy clay loam that we have out in the rice paddies over the causeway there. The plant's roots start growing and they start putting the oxygen into these real reductive soils. And everybody's like, oh, you'll get that funky smell and all that. Well, the roots start acting like pipes, pumping oxygen all around the roots. The roots are respiring. They're also adding, so they're adding all this oxygen down there. After about a month to 2 months, then everything settles down in your tank, and your tank starts growing really well. But from that point there to about a month to maybe almost 2 months, you need to do more water changes, maybe twice a week, 2 or 3 times a week, whatever it is. Some people do every 3rd day, some people do every 4th day, things like that. ADA does that. A bunch of maintenance companies that specialize in plants do that. I do that. But after, a month, basically, I kind of stop because I know those roots are really taking off and really helping the tank. And so that's true with a lot of tanks, not just planted tanks. That first month's kind of critical. So if you do the water changes, then you don't have too many problems. So that's that same tank there. And I've taken, this is old soil. All I've done is fluffed it up a little bit, pushed it that side, drained all the water down. Now I'm going to clean the tank again. I'm going to add that. And now I've got that piece of wood. And then it turns into that. I had all those plants already from the last growing season, so I added them up to the tank and added them on the wood, and now I got me this jungly looking tree weird thing, and that's what I wanted. It worked out pretty good.
How do you attach the plants to it?
What I've done several different ways. One way, I just took a drill and I just went and drilled holes, say 3/8 of an inch. Then I take these guys out, and they have a rhizome, not like anubis, and just pushed them in. And they just, and then we got that. So that's quick. That's quick. Now some people use super glue. Use the super glue, and they glue them on. That takes a long time. Other thing people do is they use string and they tie it on. You try tying string and all those little branches and knocking stuff over, and you better get into quite a zen-like state of meditation as you're doing that. Enjoy it, because it's going to take you a day or two. Maybe enlist several helpers to come over and buy them something, I don't know, pizza. The other thing is to use zip ties. Zip ties work pretty good. And so I use a sort of a mix of zip ties and the holes. Just drill the holes in the wood, and they're going to be covered up by the plants anyways. It's sort of like plugs, just like for reefs. For SPS, you put the little holes in, you have the plugs, and you buy the frags, you glue the frag, just put it in there. Oh, that coral's fighting with that coral. Oh, put it over here. So you have this sort of modularity, and you can do the same thing with the wood, driftwood. So why do we have issues adding enough fertilizers? Well, so the internet is, and also a lot of older aquarium books on plants. Good myths, hard to kill. Most problems cause too much light, not enough CO2. That's probably 95%, 85% of the problem. Those are the things that cause the algae the most. And just poor understanding about what drives plant growth really. They can adapt to lower nutrient CO2. It's like that example, that matrix I showed. They can grow at high nutrients and at high light, high CO2 really fast. They can grow at, we're not adding any CO2 and hardly any light. They still grow, they just don't grow as fast. Like if you're growing something like water sprite or valves, that's not a problem. But if you're trying to grow these Aerocarolons or some of these other more eclectic stem plants, probably not going to grow them too well in a non-CO2 low light tank. Maybe you will. Maybe you get really like, I don't know. I've seen examples where some people have grown some stuff that, but they're far and few in between. Generally speaking, you have the most success with that rich CO2 and kind of low to moderate light. That's a client's tank I did. It's a 450-gallon tank. Doesn't look it, but it is. It's 3 feet tall, 8 feet long, 2 feet front to back. That's his office. So he's got a skull here from a New Guinea headhunter he got when he was there. That's a good place. He's a CEO, so you don't want to be that guy. Talking to his employees. He's a nice guy, though. He's an very interesting guy. Different people you meet in this hobby is kind of interesting. So, kind of help people get over these myths. I found one of the better things to do is to show detailed tank journals at the time, pictures, and using the rich nutrients. Show detailed before and after pictures, like disasters of algae, post thing. Well, this is what I did. Some people have YouTube videos of their tanks, and that way you can't kind of use Photoshop so much. And a lot of them do. They love to add the red. Red plant. Ooh, how do you get your plant so red? Photoshop. So, I always ask that question. The other thing is just, can you address these issues independently of other factors? You got these new people who are like, well, I add fertilizers and I get algae. It's like, well, I add fertilizers and I don't. So if it's all about nutrients, that can't be the cause, the direct cause. You have dependency on something else. And that's a hard concept to sort of sell some of these people a lot of times, but it's true. I mean, if you think about it, all right, phosphate causes algae in planted tanks. Well, I'm adding a lot. Here's a teaspoon full of it. I just added 5 parts per million of phosphate. That's plenty to cause algae. Where's my algae? Oh, well, I add it and I get algae. Well, maybe you have poor CO2. And when you add that phosphate, plants start growing really fast, start grabbing that CO2, there's not enough, they stunt. And the algae says, hey, this is a good place to grow. And you grow on those plants. But if you focus in on plant growth, that algae should not be a problem. It should be a minor issue. If you don't, and you play these other games like, oh, we should limit this, limit that, you're probably going to run into problems time and time again. I've been telling people that for 20 years, and I still get people like, no, you got to limit this and that. No, not really, man. The plants will define the system for you. They will define that system. They will control things very well. Not so much the bottom-up control, but the plants themselves. And the plants will grow in quite a wide range of conditions. So they're the ones doing the work at preventing the algae. There's an example. So I add 5 parts per million of phosphate, at least twice a week to that tank. I add about 20 to 25 parts per million of nitrate twice a week. I add traces pretty much every day, or at least if I remember. And I feed the fish quite well. So they're getting some ammonium as well. But as soon as that ammonium is produced by the fish, it gets sucked up by the plants pretty quick. So, and then I got all these nice plants. And also, if you have a nice looking tank, a nice scape tank full of nice big red row of plants, that'll sell much better than a little scraggly one single stem in some little collectoritis tank with just a couple, looks like a zoo with each different little plant stem here and there. That sells better. And it'll sell better than any sales pitch or anything else. You put up a nice pretty picture of the plant from your tank, and that's my tank, and it's the plant you get. They buy it. They'll pay double what they get from the other guy. So that's marketing.
And no Photoshop?
No Photoshop there. I don't need it. I'm local here, so you guys can come over and, man, yeah. I can't lie. So, plants can adapt to lower nutrients and also to higher nutrients. And these are called high affinity systems. So if there's real low nutrients, the plant will make a special enzyme that's able to grab just tiny bits and amplify that into their system, keep it, hold it in really well, and get very tiny amounts from the external environment. But if there's plenty in the environment, plant changes, and it'll come up with a different transporter enzyme that'll grab a lot more, but it's less efficient. But it takes much less energy, so it's a trade-off. So if we're in a stressful situation with very little nutrients, the plant will adapt. If we have plenty of nutrients, we don't have to spend as much resources on that, and so we can grow full blast with less energy. And that's how these plants can kind of grow at these two different ranges. And that's just for potassium. I think this is from Eduardo from Davis. Columbia guy with this real intense personality and eyeballs this big. They stick out about that far. And he got right in my face in front of a group of grad students. What is it, Tom Barr? Potassium! Felt like the guy, Rodney Dangerfield, back to school when the professor tries to hit him with the thing, and he got lucky and he said it for some reason. Same thing with that guy. He left me alone for the rest of the course. So same thing again. This also works for light, the same sort of graph pattern. You can put growth or yield in light intensity or CO2 intensity here. And you get up to a point where you have too much and where you have a critical level, but you also have this big working range here. And it's the same way as CO2. CO2 is a lot more toxic, so that E would probably come real close. There's just very little wiggle room. CO2 is much more toxic. That's that other client, the guy with the skull. This is his tank at home. And those are all German wilds, angels, hemiotis. These are great fish for discus, by the way, if you have a big enough tank. Real nice companions. I told the guy to put the white sand in front because this is 4 feet tall, 12 feet long, 4 feet front to back. I've got 3 more of these tanks to do, 2 in LA and 1 in Ohio this year. So I actually get it. You've got to be in the tank for hours, quite a few hours. I'm the tank monkey in there. Algae eaters, better them than you, so use them. Shrimp are really good. SAEs, really good for black brush algae. Placos, like the bushy nose, bristle nose placos are great. They breed in my tanks really easy. So now all my tanks have them. They eat all the algae off the glass really well. Water changes. That hasn't changed since I got into the hobby when I was 7. That initial 1-2 month range that I talked about, with the soil, that works great. Plants need trimmed often, just like bonsai. Chop, 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 trim them. They grow back, chop, 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 trim them. You sell those trimmings. They're over here on the auction table. If you do a big trimming or uprooting the tank or whatever, do that water change afterwards, and that really will help to prevent algae. And there I am with water change. I just use this U-shaped PVC pipe with some of those filter screens on there. Lifeguard makes them, little strainers. And then I just hang that on there. It goes right on there and goes out the door. I use a large garden hose. It changes the water much faster than the pythons. And so I just drain it down, fill it back up, clean the filters, trim whatever I need. By the time that drains and fills, I've done all the work. Off to the next tank. Works pretty good. So, conclusion. Good horticulture is holistic. So it's CO2, light, general aquarium care, and fertilizers. You have a lot of management options though. So if you want the non-CO2 low light tank, do it. It works. You can make it look pretty too. It's up to you. There's some references from some of the folks that I sort of cited here, and also some of the slides. And there's Paul that was my tank in when I lived in Florida, going to grad school there. This I custom made that tank, and had that piece of wood sort of sticking up and out. I just found that out in the swamp, and most of the plants came from the swamp too. So, but the tank looked pretty decent. I had a big gar in there for a while, but took them back, turned them back to nature. So, I think that's it. Yep. If you guys want to copy it on your hard disk here, you can, onto the computer, and then you can use it and do whatever you want with it. Thank you. Yeah, they'll have a DVD on this, and so if you want to go back over some of the stuff or ask me later online or something, that's fine too. Any questions? You guys have time for questions? Yeah. We have time for questions? Of course. Okay. Yes, sir. Yeah, you.
I'm sorry if I missed this because I stepped out for a second, but when you talk about light, a lot of people tell me that I need to have only like 4 to 6 hours of light a day, 4 hours of light a day.
I usually,
and I go for 12.
Yeah, I mean,
it's a big difference. What's better?
Well, I use about 8.
Okay.
Something in the middle. That's what I use on all my tanks, about 8. And what I do is I set it up where one tank comes on at 5 in the morning, another tank comes on about noon, another tank comes on around 2 or 3. That way I have light in my living room all the time, so we get up in the night or before I go to bed, that kind of thing. But yeah, if you have really intense light, you add it just 4 to 6 hours, you can get away with that. If you have low light, you know, and you want to get a little more growth, maybe you can extend it out 10, 12 hours. So you just have a T8 fluorescent bulb over 55, and you have a few plants. Yeah, there's nothing wrong with that. I mean, but if you want to reduce algae, a lot of times it's more helpful if you can raise it up. You probably have too much light. Most people tend to have too much rather than not enough.
I don't get a lot of algae. I just get that really good stuff, you know, the Blackbeard. So, people's favorite.
You'd probably be good to get those SAEs, Siamese algae eaters. Get the true ones. They're pretty good at minor, BVA. BVA you can kill with peroxide. You just have like 1 mil per 10 gallons. And you can use it maybe once, twice a day. And you just turn all the filters off, squirt it around wherever it's attacked. It'll turn pink, and then but that's pretty benign stuff. It's not like the glutaraldehyde. You can use that too,
but that hurts the fish, doesn't it? Though, if too often.
If you get it above 2 parts per million, the toxicity curve starts happening around 4 parts per million.
Okay.
And usually shrimp are a little more susceptible than fish. But in general, I don't think fish really like it. Peroxide, at least you get the byproducts. Oxygen, you get a little more oxygen. You kill fish with oxygen too. You get 200 or 300% oxygen, it'll kill all your fish. They'll all be dead. I promise you. So oxygen and CO2 are good ways to kill fish. If you're just winging it. But with fertilizers, you can grow quite a bit in here. It won't kill your fish. I mean, we're talking like a factor of 10.
Right. Okay.
I've seen people do it. They just, teaspoons or tablespoons. Well, I added tablespoons. I moved that decimal point over one. Stuff like that. That's happened to a lot of people. Nobody's killed fish. With the inorganic salt fertilizers yet. Ammonia, yeah, but not the other stuff, not the nitrate or phosphate. Phosphate you can add insane amounts.
Okay.
Not harm anything. There was a question back here.
Oh, it was me.
Yes.
What lighting are you running on the 120?
I usually use T5s because I like the color from the plants, and I can kind of play around with the bulbs. They're $8-10 a piece, and I can get all these different colors pretty cheap. They last a while. That I used to have an ATI 8 bulb, high-tech thing, $800, and then the ballast burned out on it. Tried to replace it, got it working a while, and fried out again the other ballast. And I was like, this is baloney. And it happened like right before I was going to have an open house, like 2 days before. And it's the weekend. And I'm like, what am I going to do? Go down to the local marijuana growing shop. Hydroponic shop. And they had one, T8. They had 8 T5 bulbs, 48 for like $190. I'm like, it's got suspension? Yep. put it in my truck, you know, spam. I walked off with it, you know, and that's what I have on the tank now. I like LEDs, but they just, you know, for the money and the color, they're all right for smaller tanks, I think, but for larger tanks areas, it'll be another year or two, I think. We'll have pretty good stuff. Build My LEDs, they're pretty good. They're probably one of the best companies if you're going to buy an LED for a planted tank, I would say. I know the owners and talked to them. They had them at a couple events, and I've heard them talk. They actually know about lights and plants.
Who's that, Tom?
BuildMyLED.com. Guy's pretty good. He gave one of the better talks. If you guys want to have a good talk about light and LEDs, he'd be a good speaker too. Yeah. And the other thing about the speaker was George Farmer just wants that. The cost is going to be split with the SFAS too, so it's even half that. So if you guys have a relationship with them, if you guys bring out one speaker, because they have the night before they have a talk, and then I can use that same speaker here for that talk, and so you guys are getting even a better deal. Half. You're getting a cheap deal from me over here, and then plus a half again. So there's another question.
You were talking algae eaters
Yes.
in your tank, and you said the Siamese algae eaters are good. What about autosynclists?
They're
How
very
do
good.
they compare to?
They eat a different type of algae. They're
Okay.
mostly a diatom
Oh,
algae
okay.
eater. And they're real good at some of the smaller spots and little places because they're small. And if you keep autosynclists, keep a bunch of them. They love to school. You
Okay.
see a lot of tanks with just one or two left that hung on for,
Like neons.
Yeah,
One half
and
family.
they die off, and you just have one or two left that are tough as nails.
Okay.
But they like to be in schools, and but they need enough food
Right.
to eat too. And after most of the diatoms die, they eat all the diatoms that are around, and they start dying off because they don't really eat a
How
lot of the
would
other
you
foods.
support them in a tank then?
Well, I usually don't use them
Okay.
for planted tanks. I use shrimp.
Okay.
And the shrimp do
Okay.
the same thing. They pick, but unlike the photosynthetists, they breed like mad. They're
That's right.
cockroaches.
Right.
I mean, the fire red shrimp I have in my tank, they are, and that's my livestock. I have the crops,
Okay.
and then I have the cherry red shrimp. But they don't eat as well as the mono shrimp, but I have lots of them. I have hundreds of them in each tank. And I
there's
scoop
enough
out,
to keep
I
them.
kill them, I try and call the ugly ones and feed
The
them
ugly
like other
ones.
fish. I've tried to kill them because I wanted to just take out the real high grade ones, hold them off, and then cull the rest, but not kill the plants and everything else. I have no way to do that. I've tried chemicals, gas, algicides that don't hurt the plants, but so.
And they're not big enough either.
And even if I put a fish in that is a predator, they can't get them all because of the plant density.
Right.
And then they get into the filters and the tubes. It's very hard to get out. So you have to kill that too. I've tried overdosing XL and other things. I've never been able to do it yet.
Okay, so go with the Chinese algae eater, let's say, or the bush algae.
Siamese SAE, the true ones. They're good for black brush algae.
Okay.
If you have like glass algae, the bristlenose plecos, really good. If you have algae on rocks, some of the nearite snails are good. Hair algae, barbs, and American flagfish, pretty good. Barbs will eat anything fuzzy. So if you have moss, it'll also eat that too.
Oh, of course.
So, rosy barbs are very good. If you want to try and catch them again, get the long fin ones. They're kind of slow.
I love the long
The
bit.
other ones, if you want to catch a fish in a planted tank, drain the water down to about there. Nowhere to run.
25% of the
Yeah, and then, if your planted tank's sloped like this, they all come to the front and then you can get it out. Catching like that 1,600 gallon tank, the guy decided he'd get smart and add some color, and he added a bunch of pseudotrophic zebra. And if you're a cichlid person, you know that's, a pretty mean kind of fish to put in with discus and other fish, and he did it. So he regretted it, and called me down, and I spent about 2 days, and I got them all out. So, but I got paid a lot of money to do it. My rate basically is I charge as much money as if everything could possibly go wrong could go wrong, and I'd still go, "Can I help you, sir?" Now, that might be different for different people, but for me, it's pretty high money, and I don't mind doing that for that type of thing.
Right.
And so that's kind of why, I do take on clients, but I don't advertise, and it's always word of mouth, and they tend to be pretty well heeled and have large tanks and huge headaches. And
Well, we're.
that's what I get paid to do. That's not your headache, it's mine now. So you're paying me for it. So I don't mind that. That's my attitude about it. But I don't work for somebody unless I go, I'll do whatever you want. It's customer service.
Yeah.
But I'm a contractor, not a employee, so,
Right, so you
I'm only
can
as
say
good as
who
my
you're
last
gonna
job. Or as if I was a cook, a contract cook,
dish.
I'm only as good as my last meal. So that's my attitude about
Yeah.
things.
Okay, thanks.
Question?
Wanted to know if you have an opinion on split photo periods.
Opinion on split photo.
She did.
Diana Walstead asked me that question at the Agae, and I said yes. If you have a non-CO2 tank, a planted tank, it's probably a good idea. And here's why. It's not so much to get rid of algae, it's to allow the CO2 to come back up and rise, and then you have two good growing areas. After about an hour or so, when you turn the light on a non-CO2 plant tank, the CO2 is going to drop down near zero. And so if you give it a 2 or 3 hour break or split, some people just do it for viewing pleasure. I'm here in the morning, not here during the day, come back at night, I want to see the fish again, and so they turn the light on. So that might be just an aesthetics issue. So yeah, my opinion. But it's when people say, oh, it cures algae. That's hogwash, rubbish. That's sort of the fine line there. Yes, another question.
To be clear, something that will kill algae won't necessarily kill the plants, right? Two different things just because they're plants or
No, they're
photosynthesis.
fine. No, the plants just probably grow better. Other thing is, if you're adding CO2 and you're not adding quite enough, and then you give it a chance to kind of come back up again, then you see it's not really that it's the photoperiod it's doing. It's actually your CO2 management is the real root of the problem. And so that's another issue of dependency that you can kind of get and fools people. Oh, there's some trick to it. Oh, or something in nature. When the clouds come over, block it during the afternoon, and that's why. Like no, it's your root of the problem with CO2 to begin with. Non-CO2 it makes sense because you're not adding the CO2, and you're getting a little better growth. So instead of getting 1 or 2% a week, you get maybe 3. So you probably grow more species together without quite as much competition. So for a non-CO2 tank, it sounds like a good idea to me. I ain't got nothing. I can't think of any reason why not to. So that's a good sort of way to think about things too. What's a good reason why not? If you can't come up with anything, nobody else can. Try it. See.
And then glutaraldehyde. As you say, you recommend it?
Not really. No.
You don't.
You can use it, but I mean, I don't.
Well, what do you? Because you say that it's not actually a carbon supplement for the plants to use. What do you attribute the increased growth that people experience?
It's killing the algae on the plants. The plants are all covered. I mean, if you take a leaf, even a clean, my tanks and those nice clean plants, cut one of the leaves off, put it under scope, scrape the leaf or whatever, you'll find all sorts of diatoms and other algae on it. It's still there, and so that creates a little barrier between that leaf and exchange of nutrients and things. So it's called periphyton, that furry stuff on the plants, plant leaves. And then, so if you kill all that, then you can have a little bit faster exchange. So that's probably what that glutaraldehyde is doing, something like that. Killing the algae and some of the other things. Maybe it's inhibiting the bacteria that breaks down ammonium into nitrate. And so the plants are taking up more ammonium that way. I don't know. Nobody's done any tests on plant growth, submerged plant growth. Nobody's done it. If you labeled it with, say, carbon-13, did a sort of this radioactive tracer thing, you can answer that question, but that's probably $100,000 research grant for aquariums. So CCAM hasn't done that. CCAM's the guy, Greg Morin's the guy that sort of brought it into the hobby, but he hasn't done it. They're a pretty good size aquarium company. They haven't done it either. Nobody wants to fund me to do it. I can do it. I'm not really that interested in it, but I can offer a lot of info if somebody was. But that's not me.
What works best or worst filter types? HOV, wet dry, canister?
Generally, I think, kind of in that order, I would say, the wet dry works the best. It's a little challenging for a lot of people to balance their CO2 with the wet dry, but it's mostly that pre-filter. They get the pre-filter going right, like that bean animal sort of style thing. It works really well. Canister filters work really well, but you can overgas your fish. If you don't add water for top off, this applies to hang on the back and canister filters equally. If you don't add the top off water, as the water evaporates down, you just keep it pretty stable and you add that cup or two of water each day or two. Every 2 or 3 days maybe. Then that level stays the same. But if you have a spray bar and the water drops down that much, you're going to have a lot more degassing than CO2. So you're not going to have stable CO2. And a hang on the back filter, same thing. That waterfall effect is going to get really high. So if you keep that up kind of high, still have a ripple, nice ripple, just not enough to break the surface. If you keep that stable, you're probably going to be in pretty good shape. But overall, the wet dry filter can handle just a ton of abuse.
So
And
it's
it's
more
easy to
important
keep.
exactly as the amount of surface agitation and the amount of outgassing.
Yeah.
Which can be independent of the filter type.
Yeah, exactly. So you can have excellent results with all three.
As long as
Even sponge filters with aeration.
As long as you have constant minimal outgassing, which means minimal.
Just
surface
stable,
agitation.
yeah, just stable. You might get to the point where, you need to add so much CO2 it can't keep up with the degassing rate, but generally speaking, yes. Yeah, you got it. You got it.
You got one more here?
One more? Oh, last one.
Following up on his question about the filters there, so for a non-CO2 tank where you're not supplementing, somebody told me once it's actually better to get all that splash because, like you said earlier, the plants drive the CO2 down real low within an hour or two of the lights coming on.
Yeah, so you're adding
But
the
if,
gas back.
but if it's CO2 supplemented, then you wouldn't want that.
Yes.
Okay. Non-CO2 supplement's good.
Yeah, you can do that. I have tanks where I just use a sponge filter with aeration. The plants grow quite well. And I'll take plants that have black brush algae, nubus, I'll put them in there, and a month later, that nubus looks great. All of the brush algae is dead because it's stable, like we were talking about. Okay, you're done. You're ready to auction.
Thank you very much.